Welcome back to section 12.3. The last thing we're going to look at is graphing logarithmic functions. So when you're graphing logarithmic functions, we're going to make a nice little table of values and graph with that in mind. So in my example 5, the first one that I have for us is f of x equals log base 4 of x. If it helps your brain to change it to exponential form, I think you may be able to get this done a little bit faster, a little easier. In exponential form, your base is 4. That f of x is really another word for saying y. It's just in function notation, equals that middle part, which is x. Okay, so 4 to the y equals x. That would be the exponential form version of this function. So then when I'm making my xy tables, instead of choosing x's, I'm going to choose y's because y's are where everything is happening in here. It equals x. So I'm going to choose -2, -1, 0, 1, and 2 for my y values instead of choosing x values. So if y is -2, I would have 4 to the -2nd power. That's the same thing as 1 over 4 to the 2nd power, which is 1/16. Tiny number. If y is -1, we'd have 4 to the -1st power. Well, that's the same thing as 1 over 4 to the 1st, which is 1/4. All right, what about if y is 0? Then I would have 4 to the 0 power. 4 to anything to the 0 power is 1. So same thing with 4 to the 0. 4 to the 0 power is 1. What if y was 1? Well, then I'd have 4 to the 1st power, which would be 4. What if y is 2? Then I'd have 4 to the 2nd power, which would be 16. And I've got lots of points, and I can graph that a lot easier now. Okay? So let's see here. There we go. You can see my table of values. You can see my graph paper. So I'm graphing f of x equals log base 4 of x. See, the first point I had was 1/16, which is a teeny tiny x value when y is -2. So -2 for the y and a really tiny x value is very close to 0. The next one, when y was -1, x was 1/4. So a little bit bigger, a little closer to a half. Let's see, I've got the point 1, 0. I've got the point 4, 1. And I have 16, 2, which is not going to be on my graph paper because my graph goes from -10 to 10. So what I can tell you is I'm not going to go past 2 over here. I'm going to kind of probably cross around here. So let's see. On the right side, we know it's going to be increasing. And it's going to increase our y values very slowly. Our x values are going to increase faster than the y's. Okay? On this left side, what's going to happen is it's going to go closer and closer and closer to the y-axis. It's never going to hit the y-axis. It's never going to get all the way to an x value of 0, but it's going to get closer and closer and closer. We're going to get smaller and smaller x values, like what we were doing here, 1/4 and 1/16. You know, we would just keep going 1/64. We just get smaller and smaller values, but we never get to an x value of 0. Okay? So that's what that logarithm function looks like for its graph. Let's see, the second one I have for us in example B is f of x equals log base 1/4 of x. So I picked one where our base was bigger than 1 and one where our base is less than 1. Okay? Again, not touching 0 or negative values because they would bounce around and be a bit strange. Okay? In exponential form, the base of my exponent would be 1/4. The exponent would be this y value here, and it equals x. Okay? So let's go ahead and make a nice little table of values. We'll do the same thing as what we did last time. I'm going to choose y values instead of x values because that's where, you know, the action is happening in this equation. So if y is -2, we'd have 1/4 raised to the -2nd power. That's the same thing as 1 to the -2nd over 4 to the -2nd, and they're both unhappy where they are, so you can flip them around. That's 4 squared over 1 squared, which would be 16 over 1. 16 divided by 1 is 16. If my y value is -1, I would have, that's the same thing as 1/4 to the -1st power. So that's 1 to the -1st over 4 to the -1st, and they're both unhappy. We can flip them around to 4/1. 4 divided by 1 is 4. All right, what about 0? 1/4 to the 0 is just like everything else. Anything to the 0 power is 1. So 1/4 to the 0 is also 1. What about the first power? We'd have 1/4 to the first. That's 1 to the first, which is 1. 4 to the first, which is 4. And so that would be 1/4. What about an exponent of 2? That would be 1/4 to the second power. Well, 1 squared is 1, and 4 squared is 16. That would be 1/16. You'll notice it's very similar numbers to what we got in part A. Just kind of switched the order around, didn't we? Alrighty, let's go ahead and graph that and see what it looks like. So I'm going to do it this way, so we can slide back and forth again, okay? So we are graphing f of x equals log base 1/4 of x. The points we have an x value of 16, which again, I'm not going to be able to fit over here, and a y value of -2. We've got x is, we got the point 4, -1. We have the point 1, 0. Let's see, we've got the point 1/4, 1, about here, and 1/16, 2, so even closer to 0 for that one, okay? I know that I'm going to be, at x is 10, I will be less than -2, somewhere between 1 and 2. So let's see, on the right side, we are going to continue to decrease. Here we go. And on this left side, we are going to continue to basically follow along the y-axis. We're never going to touch the y-axis, but we're going to get as close as we can. Okay? So that's what those two graphs look like. So a little summary for you. That graph of logarithmic function g of x equals log base a of x is the inverse, so switching x and y values, of the graph f of x equals a to the x, okay? You'll notice instead of, that exponential, we always had the point 0, 1. For the logarithms, and we have the point 1, 0. We just switched that x and y. So you'll notice both graphs had 1, 0 in there. When a is bigger than 1, the graph increases from left to right. When a is between 0 and 1, like this 1/4 right here, it decreases from left to right. Your graph will always approach the y-axis, but never touch it. Y-axis, of course, is vertical, so we call that a vertical asymptote, where it is a line that is kind of a guiding line for our graph, that your graph basically follows along, and it gets closer and closer and closer to it, but it never touches that line, okay? The domain, then, for your x values that get used is basically going to go from 0 to infinity. It's not going to include the 0 because we never touch 0. We just get as close as possible to 0, okay? And it keeps going forever in the positive direction. The range will go from -infinity to positive infinity. I realize it's going to -infinity very slowly, or at least it feels like it, but it will keep going down, okay? We can see that positive infinity a little easier on this one. And I think on the other graph, you can see the -infinity very easily, but I promise this one, it will keep increasing. Okay, so the range is -infinity to positive infinity for both graphs. Now it's your turn. You all get to try one and show me how much you've learned.